Hello guys, we're going to continue with the rate of return analysis. One of the first steps in this analysis is that you complete an incremental cash flow table. Okay, so this table is going to look something like this. Okay, and it's going to be basically your cash flow diagram converted into a table form. Okay, so the first column where it says year, you're going to be writing down the years starting now, which is year 0, to year n, okay, if you have equal lives. Now, since remember, we're going to be using a present worth relation for our rate of return analysis. For the present worth, we need to use the LCM, the least common multiple, whenever we have unequal lives. Okay. Also, remember that for this type of analysis, we're going to be comparing alternatives in pairs. So in case you have more than 2 alternatives, let's say we have 3, you're going to be comparing the first 2, then you select one of those 2, and then that one goes against the third alternative. And that's how you do it if you have more. So you select one from the 2 and then it goes against the next one and so forth. Okay, so in this case, alternative B, okay, which is the second column right here, will be the one with the larger initial investment. So that's the first thing that you're going to take note of. Which one has a larger investment, and that one's going to go in column number 2. Okay, column number 1 will be the one with the least investment from the 2, okay, and that's the one that you're going to be putting in alternative A. Okay, then the very last column where it says incremental cash flow, well, it's going to be basically just the cash flows from alternative B, meaning column 2, minus the cash flows from alternative A, which is column 1. Okay, so you're going to be subtracting column 2 minus column 1. Okay, now let's take a look at example 6.4 and 6.5. Okay, one of them has equal lives, and for the other one, 6.5, we're going to be using LCM. Okay, so 6.4. A tool and die company in Sydney is considering the purchase of a drill press with fuzzy logic software to improve accuracy and reduce tool wear. The company has the opportunity to buy a slightly used machine for $15,000 or a new one for $21,000. Because the new machine is a more sophisticated model, its operating cost is expected to be $7,000 per year, while the used one is expected to require $8,200 per year. Each machine is expected to have a 25-year life with a 5% salvage value, and then it's asking us to tabulate the incremental cash flow. Okay, so see, okay. So the first thing that we need to note here is that both of the machines have a 25-year life. Okay, meaning that what happens here, we have equal lives. Okay, so we do not need to worry about the LCM. Okay, before starting with the table, let's draw the diagrams so that you get familiar with how everything is going to be written down in the table. Okay, so I'm going to go down here and I'm going to start drawing the first one. Okay, so it says, the very first one, it says that we have the used press. Okay, so that's the first machine. Okay, and it's 25 years. So see if I can come up with a straight line. Okay, more or less. Okay, so we're going to have year 0, 1, 2, 3. Then let me go backwards. Well, let me put the numbers. 0, 1, 2, 23, and then it goes all the way up to year 25. Let me start going down. 24, 23. Okay, so here, well, let's start with these. So this one, it says it's going to cost minus 15,000. So I have my minus 15,000. This will be my P. Then it says it has an A of minus 8,200. So I will have my A's going down. Okay, so here I'm not going to fill it out because it's the same for years 4 all the way to 22. So I still have my A going down here. Okay, so I'm just going to put that here. It continues. A is equal to minus 8,200. And then it says that the salvage value, which is going to be in year 25, it's supposed to be 5% of the initial investment. So that means it's going to be 15,000 times 0.05. So the salvage value is going to be 750. Okay, so that's how the diagram would look like for the used press. Okay, now let's draw the diagram for the new press. Okay, so this is the second option that we have. New press. Okay, so the life, it's also 25 years. Again, I have 0, 1, 2, 3. Then I have 25, 24, 23. Have the middle years, 0, 1, 2, 3, 23, 24, 25. Okay, so for this one, the initial investment is minus 21,000. Okay, the A will be minus 7,000. So again, the A is the same for the intermediate years. And the salvage value would be 5% of the P, which is going to be year 25. Salvage equals to 25,000 times 0.05. This is going to give us 1,050. Okay, so you have your two diagrams here for the used and the new press. Okay, and now we're going to put this into the table. Okay, so it's 25 years. Now, note that years 1 through 24 will have the same cash flow. So all of these years from 1 through 24 are gonna have, for the used press, 8,200. And for the new press, years 1 through 24 are going to have minus 7,000. Okay. Well, you have the A for 1 through 25, but in the 25th, you have the salvage value in addition to the A. So the way we're going to fill out the tables for equal lives, note that this is only for equal lives. Okay, so instead of having, well, let's write year 0, but instead of having years 1 through 25 one by one, what you can do here is write years 1 through 25, because in years 1 through 25 you're going to have the same A. But then for the salvage value that occurs in the 25th year, you have to add the 25th year here. Okay, if you don't have a salvage value, then you don't have to add year 25 on its own. Okay, so for alternative A, okay, the P is minus 15, so minus 15 occurs in year 0. So we're going, well, first of all, alternative A was that it's the one with the least investment. Which one has the least investment? The used press with minus 15 or the new press with minus 21? Okay, so alternative A will be the used press. And alternative B, the larger investment, will be the new. And this is our incremental cash flow. Okay, so the used one, we said that this is minus 15,000. This is what occurs in year 0. Then from years 1 through 25, we have minus 8,200. And then in year 25, in addition to the A, we have the salvage value, which is 750. Then for alternative B, we do the same thing. Okay, in year 0, we have minus 21K. Then for years 1 through 25, we have minus 7,000. And for the salvage value will be 1,050. Okay, note which ones are negatives and which ones are positives. So just translate it into the symbols. Okay, year 0 will be your P. Years 1 through 25, this is your A, and year 25 is your S. Okay, so now we are ready to compute the incremental cash flow. Okay, now here, let's go with column 2. So it will be minus 21,000 minus 15,000. So here, yes, if it's a minus right here, it doesn't matter if the other column has a minus or a plus sign. Okay, so here you're going to subtract a minus amount. Okay, so here you're going to be getting minus 6,000. Then the next one will be minus 7,000 minus 8,200. You will get 1,200. And then the last one is 1,050 minus 750, which will give you 300. Now these three numbers that you see here are going to be the answers for your incremental cash flow table. Okay, so these numbers, we're going to be using them for our next step. Okay, so that's example 6.4. Okay, now before we jump into the next step, we're going to be learning another way to fill out this table. Okay, so let's go to example 6.5. Okay, so for example 6.5, it says Sanderson Meat Processors has asked its lead process engineer to evaluate 2 different types of conveyors for the beef cutting line. Type A has an initial cost of $70,000 and a life of 3 years, and Type B has an initial cost of $95,000 and a life expectancy of 6 years. The annual operating cost for Type A is expected to be $9,000, while the annual operating cost for Type B is expected to be $7,000. If the salvage values are $5,000 and $10,000 for Type A and Type B respectively, tabulate the incremental cash flow using their LCM. Okay, so in this case, it says right here that we will be using the LCM. So this problem is for LCM. The previous one was for equal lives. Okay, so what are the lives here? We have 3 years for this one and 6 years for Type B. Okay, again, before filling out the table, we're going to draw the diagrams first. Okay, so let me go down. Okay, so I'm going to go all the way over here. So we said that since we have different lives, okay, we're going to get the LCM, which in this case it's going to be 6 years because we have 3 and 6. Okay, so the LCM will be 6. Okay, let's go over type A. Okay, type A, okay, is for 3 years. So how many times can we fit those 3 years into 6? 2. So therefore, for type A, we're going to have 2 cycles. Okay, so we're going to draw the cash flow diagram for 6 years. Okay. Here the first cost will be minus 70,000. Okay. Then the A here is minus 9,000. So I will do the first cycle first. Okay, so I have A minus 9,000. And the salvage value will be 5,000. This is the first cycle, but we need to repeat it. Now remember that the last year for the first cycle becomes year 0 for the second cycle. So in year 3, we have our initial investment again. We continue with our A's, and in the last year, we have our salvage value again. Okay, we do not put another minus 70,000 in year 6 because we are not starting another cycle. Okay, so just make sure. So it's 0, 0, 1, 2, 3. It's 0, 1, 2, and 3 for the second cycle. Okay. Now let's go with type B. Okay, so we have type B. Okay, so the life for type B is 6 years. So here we only have one cycle because the LCM is 6 years. Okay, so we draw it for 6 years. Okay, so here the initial investment will be minus 95,000. Okay, and we have A going down in every year. So this is minus 7,000. Okay, and then we have the salvage value in the 6th year, which is going to be 10,000. Okay, now we need to put these values into the table. So right now we're not solving anything. We're just going to copy those values in the respective years. Okay, so let's go up to the table. Whenever you have different lives, you have to put all of the years individually. Okay, so in this case, we would have to put, you see, year 0, 1, 2, 3, 4, 5, and 6. Okay, but we need to decide which one is alternative A and alternative B. Okay, not because it says type A and type B, you're going to match them. So type A has an initial cost of 70,000 and type B has an initial cost of 90,000. Alternative A is the one with the lower initial cost. So in this case, yes, type A will be alternative A. And alternative B will be type B. And this is our incremental cash flow. Okay, so now let me fill out the table. For alternative A, what do we have? We have in year 0, we only have the minus 70,000. Okay, and then years 1 and 2, we have minus 9,000, but year 3, we have 3 things going on. we have the minus 9,000, we have minus 70,000, and then 5,000 going up. Years 4 and 5, we only have the 9,000. And year 6, we have two cash flows here. We have the minus 9,000 and a 5,000 going up. Okay, so we need to include all of these per year. Okay, so let me go back to the table. And this is just for alternative A. Okay, so in year 0, we have minus 7,000. Year 1, we have minus 9,000. Year 2, we have minus 9,000. Year 3 is where we had the three cash flows, so we need to put them together. Minus 70,000 of the repeated initial investment, the minus 9,000 of the A, and plus 5,000 of the salvage value for the first cycle. Okay. Then year 4, we only have minus 9,000. Year 5, minus 9,000, and in year 6 we have the minus 9,000 for the A plus the salvage value for the second cycle. Okay, so this is what we're gonna have for alternative A. Now if we go to alternative B, okay, this one's easier because we don't repeat any cycles. So in year 0 we have minus 95. Years 1 through 5 we have minus 7,000 only, and in year 6 we have the minus 7,000 plus the salvage value. So the only one that will have two cash flows will be year number 6. Okay, so let's go down, up here. So we're going to start with minus 95,000 minus 7,000 minus 7,000. So every year we're gonna have minus 7,000 until we get to year 6. We have the minus 7,000 plus 10,000. Okay, so now we are ready to calculate our incremental cash flow, which is basically column 2 minus column 1. So in the first one we're gonna have minus 95,000 minus 70,000, okay, which is going to give us minus 25k. Then the next one, minus 7,000 minus 9,000. This one is going to give us 2,000. Okay, then the next one is the same. We have the same numbers, so we're going to get 2,000. Then this one changes, so this is minus 7,000 minus, and we're going to put all three of them, minus 70,000 minus 9,000 plus 5,000. Okay, this is a minus sign. Okay, this one will give us 67,000. Then year number 4 is the same as years 2 and 1. Okay, year number 5 is the same. And year number 6, we have 2 on each. So we're going to have minus 7,000 plus 10,000 minus 9,000 plus 5,000, which will give you 7,000. Okay, so all of the results, these results are going to be the ones that we will be using in our present worth relation. Okay, so how are we going to use these numbers? In the previous example, it was hard, it was easy to identify the P, the A, and the S, but this one it's a little bit harder to see. So in order to do that, I will redraw, or I will draw another diagram, a third one, with these cash flows. Because, okay, so for now, you can say that, yes, in year 0, this one right here will be your P, right? But then, and then you see here that you have 2,000 repeated for some of these years. Okay, so what do you think this is going to be if you have 2000 in each year? Now, yes, you have 2000 in years 1 and 2, but then in year 3 you have 67, and then in year 6 you have 7000. Okay, so let me draw a diagram with these cash flows. Okay, the ones I circled in yellow, so that it's easier for you to identify what symbol they correspond to. Okay, so let me go. I'm gonna put it here. So the incremental cash flow diagram, this is for 6 years. Okay, so we said year 0 we have minus 25,000. Okay, so I have minus 25,000. Then we have in year 1 and 2 we have 2,000. Okay. Then year 3 we have 67. Oops, sorry, the 2000s are supposed to go up. Okay, so yeah, you have 2000, 2000, and then 67,000. Then we have 2000 and 2000 for years 4 and 5. And then year 6 we have 7,000. Okay, so yes, we said that this one would be your P. Do you see any uniform series? Okay, so we have the 2000 years 1, 2, 4, and 5. Actually, yes, we do have uniform series. Our A here will be equal to 2000. Okay, why? Because you have, yes, you have 2000 here, 2000 here. Here you can fit the 2000. You have the 2000 here, 2000 here, and here in this 7000 you can fit the 2000. Okay, so our A will be 2000. Okay, what happens with the remaining numbers? So here for A I will put 2000. Okay, but what happens to the 67 in year 3? Okay, so the 67 in year 3, okay, will be equal to, okay, so we have 67, okay, which will, you're gonna break it down into 2 parts. What's a 67,000? Okay, it's gonna be the 2000 for the A plus another 65,000. Okay, so this one right here is, we said it's the A. So what's left? What do you think this is going to be? Okay, remember that we have a present worth relation. Okay, so this arrow right here is going to be an F in year 3. Okay, so eventually we will convert to P, so this one we have to move it to year 0 with find P given F. Okay, so this 67 will be 2000 plus 65,000. Okay, and the 65,000 will be, this is your A, and this is an F in year 3. Okay, and then the last one, we have this 7,000 right here. Okay, so this 7,000 will be equal to the 2,000 that we took away for the A plus 5,000 more. So this is part of our A, and what do you think this is going to be, the 5,000? Well, yes, it's going to be an F in year 6, or our salvage value, okay, which is a F in year N. Okay, so therefore this 7,000 that we have here will be 2,000 plus 5,000, which is your A and your salvage value, or your F in year 6. Okay, and that's how you would translate the results of your cash flow, of your incremental cash flow table, how you would put them in a diagram form. Okay, so next class we will continue with the following steps to solve our rate of return analysis problems. Okay, let me know if you have any questions. Feel free to email me over the weekend. Thank you guys. Have a nice weekend. Bye bye.